Hi guys, my name is Divyang and welcome back to IGCSE on Fingertips. Today we are going to solve Physics Paper 2-3 of May-June 2021. The paper is of 45 minutes, it's an MCQ type question. Let's get started. The first question is, diagram shows a plastic rod alongside a ruler. Okay, what is the length of the rod? Now we have not been given each point, right? So we'll have to find that out. Between 0 and 10 there are 5 divisions, correct? So each division is going to be 10 divided by 2, right? So I'm sorry, each division is going to be 10 divided by 5, which is equal to 2 units. So this will be 2, 4, 6, 8, right? This will be 2, 4, 6 and 8. Now we have to find the length of the rod. The rod extends from 2 centimeter to 9 centimeter, right? We can only estimate a between number between 8 and 10, it can be 9, right? We don't have accuracy more than that. So from 2 to 9, the total length will be 9 minus 2, that is 7, and the ruler is of centimeter scale. So our correct answer will be C, 7 centimeter. Question 2, 4 balls, okay, 4 balls with different masses are dropped from the heights shown. Air resistance may be ignored. Which ball has the smallest average speed? Now for the ball to have smallest average speed, it must fall from the least height. The mass of the ball does not affect its speed because everything gets pulled by the gravity of earth equally, right? So the ball which has lowest height from where it falls is A. So our correct answer is option A. Question number 3. A cyclist rides 300-meter up a slope in 50 seconds. She then rides down the slope in 25 seconds. What is her average speed? The formula for average speed is total distance upon total time, right? Now, if she is going up the slope 300 meter, we are going to assume that when she comes down, it's again going to be 300 meter. So 300 meter on each side, 300 meter on each side is 600 meters. The total distance is 600 meters and the total time taken is 50 plus 25, which is 75. So 600 upon 75, right? On doing that in your calculator, you will find that the average speed is 8 meters per second. Option B. Question 4. An object is on the surface of the earth. Which statement describes the weight of the object? What is weight? Weight is the gravitational pull, right? It's the gravitational force. Let's find out. Do we have an option like that? The quantity of material that the object contains? No. Quantity of space that object takes up? No. The gravitational force acting on the object? Yes. So our correct answer is option C. Going to the next question. Question 5. The tank shown has dimensions 5 meter into 4 meter into 4 meter. It is completely filled with water of density 1000 kilogram per meter cube. What is the mass of water in the tank? To find that out, right, we know density is equal to mass upon volume. Therefore, mass will be density multiplied by volume, right? Density is already given as 1000. Volume could be found out by multiplying length, breadth and height, the dimensions given of the tank. So 4 4s are 16, 16 into 5000, right? 16 5s are 80. So 80,000 kilogram, right? Because the density is in kilogram per meter cube. So our correct answer is option D. Question number 6. The extension load graph for a spring is shown. The unstretched length of the spring is 17 centimeter. When an object is suspended from the spring, the length of the spring is 19.2 centimeter, right? So what happens? The extension is 19.2 minus 17, which is 2.2. Okay. What is the weight of the object, right? What will be the weight? The force that causes this extension will be our weight. Now let's look at what is the graph given. The graph is given is extension versus load. Load is nothing but the weight. So we'll find out for extension of 2.2 centimeter, right? What is the load? The load required to have this extension is 3 Newton, right? Let's find out, do we have a 3 Newton option? Yes, we do. That is option D. Let's go to question 7. A car of mass 1200 kg is traveling along a horizontal road. Frictional force is 1000 Newton, driving force is 4000 Newton, and it's going from left to right. Correct? Now, they're asking what is the acceleration of the car. We know acceleration can be found out by the formula of force, that force is equal to mass into acceleration. Now, what force shall we take, right? Because there is a total frictional force of 1000 Newton opposing the driving force, right? Because frictional force is opposing the driving force, our resultant force is going to be 4000 minus 1000, which is equal to 3000 Newton, right? Now we have the force, we have the mass of the car, we can easily find out acceleration. Acceleration is nothing but 3000 divided by 1200, that is the mass of the car. Calculating that value, we have 3000 divided by 1200, we have 2.5 meters per second square. That is option C. Okay, let's see what's the next question. Question 8. Object X moves to the right along a frictionless surface towards a stationary object Y, as shown. They make a noise as they collide, and then both objects move towards the right. Which is the correct equation? Now when they make noise, they are trying to tell us that some energy is lost, right? Now if some energy is lost, then we cannot equate the energy, right? But we can equate the momentum. We know initial momentum will be equal to final momentum, correct? Let's find an option that agrees with this. Change in momentum of X is equal to change in momentum of Y. No, that is incorrect. Why? Because the initial momentum of X and Y will be equal to the final momentum of X and Y. It's not so that the change in momentum is equal. If their masses are different, the change in momentum might be different. Impulse of force acting on X is equal to impulse of force acting on Y. No, this is also incorrect, because change in momentum is not equal. Force will definitely be unequal. Kinetic energy of X before collision is equal to kinetic energy of X plus kinetic energy of Y after collision. No, that will not be correct, because some noise is given out, and yet we do not know if any other energy losses are there, right? But momentum of X before collision is equal to momentum of X plus momentum of Y after collision. Now see, ideally what should happen? Initial momentum should be equal to final momentum. So the first momentum of X and Y, the momentum of X and Y before collision should be equal to momentum of X and Y after the collision, right? But Y is stationary, so its momentum is 0. Therefore, the statement D is correct, that the momentum of X before collision is equal to momentum of X plus momentum of Y after collision, as after collision they both move towards right. Okay. Question number 9. A stream flows out of a lake and down the side of a hill. A stream flows out of a lake and down the side of a hill, which best describes the change in energy stores. So if it is at a height, when it's coming down, its potential energy is getting changed to kinetic energy. Let's find an equation that tells us that. So gravitational potential energy is changed into kinetic plus internal energy, that is option B, and gravitational potential energy plus kinetic energy is changed into internal energy. Now see, if the stream is moving, it does have kinetic energy, but here that movement is not because of kinetic energy, because it is flowing, right? It is falling down a hill. So option B will be correct, that gravitational potential energy is getting changed into kinetic and internal energy. Now internal energy is nothing but because it might get heated, it's going to create some sound, it's going to fall on some rock and maybe wither them. So that is internal energy. Right? Question number 10. The energy input to a device is E. The amount of energy wasted by the device is W. Which expression gives the efficiency of device? Now we know that efficiency is equal to output upon input into 100. Right? It's output upon input into 100. Now if input is E, then the denominator becomes E. If E is input and W is wasted, then the output is difference between input and waste into 100. Let's find out what option this agrees with. It is option C, E minus W whole upon E into 100. Okay, next question, question 11. A builder lifts 30 bricks from ground to a platform 2-meter high. Each brick has a mass of 4 kg. What is the work done against gravity by the builder in lifting the bricks onto the platform? Now we know work done is equal to force into displacement, right? The displacement caused by this force, multiplication of that is work done. Now because we don't have force, we are going to find out the weight of bricks. So we have weight into displacement. But again, because we have been given mass, I can change this equation to mass into gravitational acceleration into the displacement. What is displacement here? Displacement is nothing but the height through which this has to be raised. In other words, work done is equal to the increase in gravitational potential energy. To find that out, let's just quickly multiply the mass, gravity and height. So the mass of one brick is 4, right? There are 30 such bricks. The gravitational acceleration is 10 meters per second square, or we can take G as 10 Newton per kilogram. And then we will take height. It has to be raised through a height of 2 meter, right? So 12 to the 24, your answer is going to be 2400 joules. The energy required, the work done in doing this is 2400 joules, which is option D. Question 12. A book has a mass of 400 gram. The surface of the book is in contact with a table, has dimensions 0.10 meter into 0.20 meter. The gravitational field strength G is 10 Newton per kilogram. What is the pressure exerted on the table due to the book? Again, let's start with the main equation. Pressure is equal to force upon the area on which this force is exerted. Now, this force is nothing but weight here upon area, but weight can be calculated by the mass into gravitational pull upon the length into breadth given, right? So mass for this is given as 400 gram, but our gravitational field strength is in Newton per kilogram. So I'll change this to kilogram to 0.4 kilogram. So I'll write 0.4 multiplied by 10 upon 0.1 into 0.2, right? Let's quickly find that out. 0.4 into 10 divided by 0.1 into 0.2, which is equal to 200 Newton per meter square, the unit of pressure, right? Next question. Question 13. Diagram shows a tank full of water. The mass of water in the tank is m. Density of water is given rho. Height of the water in the tank is h. Which equation gives pressure due to water at the bottom of the tank? It is simply given by P is equal to h rho g. Height into density into the gravitational field strength. Okay. Question 14. A liquid at room temperature is put on a metal surface which is also at room temperature. The student blows gently across the liquid and its temperature decreases. What causes the liquid to become cooler? Now see, if the liquid is at room temperature and it's put on a metal which is also at room temperature, surely when this student actually blows some air, what is going to happen? Evaporation is going to happen. In evaporation, what happens? Let's find out from our options. Bubbles of water vapor form in liquid and go into the air. No, bubbles do not form because there is no external heating. Moving air reduces the kinetic energy of all the particles in the liquid. It is not so. Thermal energy flows from liquid into the metal. Now this can also not happen because both of them are at the same temperature. D. The more energetic particles in the liquid escape into the air. Yes. What is actually happening? Evaporation. The more energetic particles in the liquid escape into the air. Okay. Question 15. A very small pollen grains are suspended in water. A bright light shines from the side. Okay. When looked at through a microscope, small specks of light are seen to be moving in a random, jerky manner. Okay, what are moving specks of light? The moving specks of light are the pollen grains, right? We can only see pollen grains. We are not able to see the atoms of water molecules, right? So when this bright light is reflected by pollen grains, we can see those specks of light that are pollen grains. Now why are pollen grains moving? They are moving because they are being hit by water molecules. Now water molecules are not visible, but the specks of light are visible. So what are the moving specks of light? They are pollen grains being hit by water molecules. Option B. Okay, next question. The liquid level in a thermometer rises when thermometer is placed in hot water. What causes this? That rise in the level of thermometer is due to the expansion of thermometric liquid, right? So option C, the liquid expands. Question 17. A student calculates energy needed to raise the temperature of an aluminium block from 50 degree to 60 degrees Celsius. He then uses an experiment to measure the energy used to do this. So what he is doing, he is first theoretically finding an answer, right? And then he is practically trying to verify his answer. Is it correct or not, right? So what will happen when he has theoretically found out the answer? He must have used formula H is equal to mc delta theta, right? mc delta theta, which will give him the heat required to raise the temperature of water for whatever mass he takes for 10 degree difference, right? But when he does this practically, what will happen? Some of the heat he supplies is lost, right? Some of the heat he supplies is lost to the environment. It may be required to heat the container, right? It may be lost due to convection, right? There are many losses possible. So what will happen? Which statement about the measured energy is correct? A. The measured energy will be greater than calculated energy because some energy is transferred to the surroundings. Yes, this makes complete sense. He measures the energy, okay, in the experiment. It's going to be greater than the energy that he has calculated practically, because in this one he has not considered, in calculation he has not considered any losses. So option A is the correct option. Okay, let's go to question 18. Which row correctly describes a liquid that is boiling? Okay, so are bubbles seen? Yes, they are seen. Where it takes place in the liquid, the bubbles are seen throughout the liquid, right? When liquid is boiled, the whole liquid will start boiling altogether. Option D is the correct answer. Okay, question 19. Three students are planning an experiment to test the thermal conduction in different materials. The student each propose a hypothesis. Number one, I think copper rod will be a good thermal conductor because it is a metal. So student number one says that copper rod is a good conductor because it is a metal, which is true. His hypothesis is correct. We don't know how they are going to plan or prove it, but his hypothesis is correct from the known facts. Student 2 says, I think glass rod will be a good thermal conductor because it has free electrons which vibrate and transfer energy quickly. Now, glass rod is not a good conductor of electricity or heat, right? And he is saying that it will be a conductor because it has free electrons. Now, glass rod does not have electrons. Then he is going on to say which vibrate and transfer energy quickly. Now, if there are free electrons, they are going to travel from one end to another to transfer energy, right? Electrons don't vibrate, lattice vibrates. Electrons actually move about, right? That is why copper is a good conductor of electricity because it has a sea of electrons that are delocalized. It can move from one end to another end, right? So his hypothesis is incorrect. So first one hypothesis is correct, the second one's hypothesis is incorrect. Third one says, I think wooden rod will be a poor thermal conductor because it can only transfer energy along the rod by vibrating lattice particles. Now his hypothesis is correct. Yes, wood is a poor thermal conductor. That's why in cooking we make spatula of wood so that it does not get really hot. Now it can transfer energy only along the rod by vibrating lattice particles. If it had free electrons, it would have been a good conductor. So it does not have electrons which are free to vibrate and transfer the energy from one end to another, travel from one end to another, right? But the lattice particles are present. Wood is a solid, it will have a lattice. Its particles are vibrating. So at some point, other end of the wood will also get a little bit hot, right? Not as quickly as metals, but it will. So the hypothesis of third student is also correct. Which of their hypotheses are correct? Only 1 and 3. So 1 and 2 only? No. B. Only 1 and 3. Let's go to question 20. Question 20. A copper plate is shiny on one side and is painted dull black on the other side. The plate is heated to a high temperature. A person places his hands at equal distances from either side of the plate, close to the plate but not touching it. So this is a very hot copper plate. One surface is shiny, one surface is dull. Why does the hand near the dull black surface of the plate feel much hotter than the hand near the shiny surface? Because shiny surface are not good radiators. Dull black surface is a very good radiators, right? Option A, the dull black surface is a better emitter of radiation than shiny surface. So our option A itself is correct, right? Let's go to next question, question 21. A water wave passes into a region where water travels more slowly. As it passes into the slow region, what happens to the frequency and what happens to the wavelength? Now we know frequency can never change of a wave. Frequency can never change. It always remains a constant. And if, let's first write V is equal to F lambda. This is the equation for relationship between the velocity, frequency and wavelength of a wave, right? If it travels more slowly, meaning if it gets slower and this frequency is constant, if velocity decreases for constant frequency, the wavelength must decrease. So let's find an answer that agrees with that. So frequency stays constant, wavelength decreases. Frequency remains the same and wavelength decreases. So option C is the correct option. Okay. Question 22. Light traveling at a speed of 3 into 10 to the power 8 meters per second strikes the surface of a glass block and undergoes the refraction as it enters the block. The diagram shows a ray of this light before and after it enters the block. What is the speed of light in the glass? Now to find that out, we have to know the refractive index, because refractive index is the speed of light in vacuum upon the speed of light in given medium. But we also know refractive index is nothing but sine of angle of incidence upon sine of angle of refraction. Right? Now using this equation, I can write sine I upon sine R is equal to the velocity in free space or vacuum and velocity in this particular medium. Rearranging this equation, velocity will be speed of light into sine I and the whole thing divided by speed of light in vacuum into sine R upon the whole thing divided by sine I. Let us quickly do this in our calculator. So the speed of light in vacuum is given to us, right? 3 into 10 to the power 8, right? And sine R. So sine R, the refracted angle is 33 degree, right? This is R, and incident angle is 55 degree. So this is I. Right. So when you find sine R upon sine I and multiply it with C, so you have 3 into 10 to the power 8 multiplied by sine 33 divided by sine 55, right? You get 2 into 10 to the power 8 meters per second. This will be the speed of light in glass. That is option B, right? That is option B. Okay. Question 23. A beam of light is monochromatic. What does monochromatic mean? The frequency of all the light rays is equal. All the waves in the beam must have same frequency only. Yes, that is our correct answer. Option A. Question 24. An object is placed in front of a thin converging lens. Diagram shows the path of two rays from top of the object. Okay, an image of the object is formed on a screen to the right of the lens. So, how does this image compare with the object? Now, for this, let us actually just take the image first, right? Let's first find out where the image forms. So one ray goes like this. When it passes through the center of the lens, the ray goes unrefracted, right? Let's take another ray and just trace it forward. This has already passed, the other ray has already passed the lens, so we don't need to draw any refraction for that as well. Both rays going like this. Now if you see, then you can say that the image forms somewhere here. Now it is further away from the object, right? The distance of object and lens is less than the distance of image and lens. Therefore, image is going to be larger. The first thing is image is going to be larger. It is also inverted. If you see, the top of the image is inverted, right? The image is upside down. So option A, it is larger and inverted. Yes, this is the correct option. Let's go to question 25. Which row correctly describes what happens to the frequency and to the speed of electromagnetic waves as we move through the spectrum from gamma to radio waves? Now, when you go from gamma to radio waves, let us just write down that the gamma rays have frequency of 3 into 10 to the power 21 hertz, right? And radio waves start from the frequency of 3 into 10 to the power 11 hertz, right? The frequency goes on decreasing and the wavelength goes on increasing, right? That is how by the wave equation V is equal to F lambda, the velocity remains constant. The frequency from gamma to radio goes on decreasing and the wavelength goes on increasing, and that is how the velocity, the speed of this EM spectrum is constant. So what happens to the frequency? The frequency decreases. What happens to the speed in vacuum? It remains the same. So frequency decreases, this remains the same. Option B is the correct answer. Let's go for next question, question 26. The diagram shows a model of a sound wave passing through air in an open tube. What is the region Q? Okay, Q is here, right? Now we are not seeing many particles near Q, right? So what it must be? It must be rarefaction, right? In this region the particles are very near. Again in this region the particles are very near. Again in this region the particles are very near. Again in this region the particles are very near. All the region in between 1, 2, 3, 4 could be said that the particles are less, and therefore they could be said they are rarefaction. So what is region Q? It's a compression, no, rarefaction. Okay. Which is a region of high pressure? No, rarefaction is a region of low pressure. So your correct answer is option D. Okay, question 27. The sound from a loudspeaker must pass through two materials to reach a microphone, material 1 and material 2. Which combination of material gives the shortest time for sound to reach the microphone? Now, just writing down the equation for speed is equal to distance upon time. Now, material 1 and material 2's thickness will be same, right? Whatever material we take, their thicknesses will be kept constant. That is what we assume. So, to take the lowest time, right? To take the lowest time, the speed must be highest. So basically they are asking which of these combination of materials will give you the highest speed for sound. Okay, the sound travels highest with highest speed in solids. So let's find out, do we have a combination of solids? Air and hydrogen, not solid. Air and water, okay, there's a liquid but not solid. Then copper and aluminium, yes, these both are solids. D option is water and oil, again liquids. So sound travels fastest in solids, and your option C is the correct option. Question 28. A bar magnet picks up two steel bolts. Which diagram shows the magnetic poles induced in the bolts? Now what happens is, steel is a temporary magnet. Steel can be made into a temporary magnet. What happens with a temporary magnet is that when south pole is attracting a temporary magnet, the point of attraction from where this temporary magnet is attracted, it becomes north pole, the opposite one becomes south pole, and this keeps on happening, right? So we must find an option in which this is happening. If this is south pole and this is south pole, this attraction will never happen, right? If there is south pole induced here, this attraction will never happen. Again the same thing goes here, this will never happen. North south north, yes, but again if this is south pole, then south pole can't be induced here. Let's look at option D, south north south north south. Yes, in this one everything seems to be correct, and D is our correct answer because it has the correct polarity on the steel nails. Question 29. A student rubs a plastic rod with a cloth. The rod becomes positively charged. What happened to the rod? The rod, when it becomes positively charged, now positive charges cannot move, only negative charges can move. So in short, if it becomes positively charged, it has deficiency of negative charge, right? There is deficiency of negative charge. So negative charges have moved out. What are negative charges? Negative charges are electrons. So what happened to the rod? it has gained electrons. No, it has lost electrons, right? So option A and B are incorrect. C is it has lost electrons. So option C is your correct answer. Question 30. An isolated metal sphere is positively charged. It is then brought near to another isolated metal sphere that is neutral. Okay, so if positively charged metal sphere is brought against neutral metal sphere, if it's brought near, then what happens to the charges on the neutral sphere as the positively charged sphere is brought close to it? Now, if it is brought close to it, because this is positively charged, right, the negative charges on the right hand side get attracted, so there will be an accumulation of negative charge on the left hand side of the sphere. Now because these positive charges have been attracted, they have moved towards left, there will be an accumulation of positive charges on the right. Correct? What is moving? Electrons are moving from right to left, which gives rise to negative charge accumulation on left hand side and positive charge accumulation on right hand side. Okay, let's look at our options. Some positive charges move. No, they don't. Some positive charges move. No, they don't. You don't even need to read further because this fact is incorrect. Again, some positive charges move. No. The positive charges do not move, but some negative charges move to left. Yes, this is the correct option. Question 31. The diagram shows a circuit containing a cell, two resistors, a switch and a voltmeter. Okay. When the switch is open, the voltmeter reads 1.5 volt. When the switch is closed, the voltmeter reads 2 volt. What is the electromotive force of this cell? For this, let us trace the path of the current. So let's say current starts from here, it goes here, 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 and it passes through this first resistor. So it loses some voltage here, right? So it passes and then it loses some more voltage here, but this is calculated as 1.5 volt, right? Now the current goes back and the circuit is complete. So in this case 1.5 volt is measured. Now let us see what happens when this switch is connected, right? When this switch is connected, what actually happens is current again starts from here, goes here, but because current takes the path of least resistance, right, and there is a resistor here, so current does not want to go here, it will travel from this path. So there is no voltage drop now. In this resistor the current does not pass and there is no voltage drop, therefore it passes from here, again it passes from here. Current does not pass from voltmeter as well because voltmeter has a almost infinite resistance. The resistance of voltmeter is very high, so current is not going to pass through it and therefore it will pass through here. So there is no voltage drop except this resistor, and that is measured by our voltmeter. What is it? It is 2 volts, right? So what is the total voltage provided by this particular cell? It will be equal to 2 volts because there is no other voltage drop, right? So option C is our correct answer. Let's go to the next question. Question 32. A 4 ohm resistor and a 12 ohm resistor are connected in parallel. What is the effective resistance of this combination of resistors? Now as they are connected in parallel, right, the effective resistance is 1 by R effective is equal to 1 by R1 plus 1 by R2. Now what is R1 and R2? R1 and R2 is nothing but 4 ohm and 12 ohm. So 1 by 4 plus 1 by 12. On taking LCM and adding them up, you get 4 by 12. Reciprocal of this because we want to find RE. RE is 12 by 4, which is equal to 3. So the effective resistance is 3 ohms, which is option B. Question 33. Which combination of the two gates will result in the truth table shown? Now let us first understand what is the truth table, right? What is the gate, a single gate that can give us this answer? 0 0 gives 0, 0 1 gives output 1, 1 0 gives output 1, 1 1 also gives output 1. This is a case of OR gate, right? If either of P or Q, right? If P or Q, either of them are our input, sorry, if either of them are 1, the output is 1. Output is 0 if and only if both of our inputs are 0. This is a case of OR gate, right? Let us find out which of these combination gives us OR gate, right? So this is a NAND gate, right? It's a AND gate with NOT, and this is an AND gate. Oh, this is a NOT gate, right? So NAND and NOT will be AND, right? This output is going to be AND. This is AND gate and this is NOT gate, right? So output is going to be NAND, right? This is NOR gate and this is NOT gate. The output is going to be OR, right? What is the gate that we are finding? We are finding an OR gate. So our correct answer is option C. Our correct answer is option C. Okay. Next question, 34. A solenoid is connected to a very sensitive ammeter. A rod is inserted into one end of the solenoid. The ammeter shows that there is a small electric current in the solenoid when rod is moving. Which rod is being inserted? Now what is happening? If you see a small current, EMF is being induced, right? So we have induced EMF. When does EMF get induced? When the magnetic flux is cut. So what should the rod have? It should have some magnetic field of itself. So which rod is being inserted? A heater copper rod? No. A magnetized steel rod? Yes. Only then EMF can be induced. Okay. Question 35. A 12 volt 36 watt lamp shines at normal brightness when connected to a mains transformer. Assume that transformer is 100% efficient. Which row shows the number of turns in secondary coil and current in the mains wire? So we need to find the number of turns of secondary coil and current in the mains wire, right? Now for a transformer which is 100% efficient, we can write number of turns of primary coil upon number of turns in secondary coil is equal to voltage of primary coil upon voltage of secondary coil, right? Using this relationship, I can write number of turns in primary is 1200 divided by voltage in primary is 240, sorry, number of turns in secondary are to be found out. So that I don't know, let's take it as X. Voltage in primary is 240 and voltage in secondary is 12. Let's quickly find out. 12 20 times 0 0 to 60 times, right? So your X is equal to 60. So the number of turns in secondary coil is 60, right? Now we have to find the current in mains wire. Now to find that out, see, if the transformer is 100% efficient, then it is also true that 36 watts of power is on secondary side. The mains is also supplying the same power, right? So power is equal to V into I. Electric power is voltage into current. So our power is 36. We know the voltage is 240 in mains and we need to find the current. Current is equal to 36 upon 240. Doing this in your calculator, you have 0.15 ampere. So let's find an answer that gives this number of turns on secondary coil and current in the mains wire 60 and 0.15. The correct answer is option A. Question 36. Diagram 1 shows a wire carrying an electric current into the page. The wire is between poles of a magnet. A force is produced on the wire acting down towards the bottom of the page. Diagram 2 shows the situation after the current is reversed and the magnet is turned through 90 degree. Now the wire is already carrying current and there are magnetic poles. This is a case similar to motors. In motors we apply current to get motion, right? The direction of force is nothing but the direction of motion in case of motors. So we'll use our left hand rule, right? So this is the direction of magnetic field. The second finger gives us the direction of current, right? So it goes like this, and our thumb gives us the direction of force, which is this diagram. Now what is happening? The direction of current is reversed, so the current is coming outwards, right? So north to south, this is the direction of the magnetic field, this is the direction of your current, and therefore towards the left is the direction of force experienced by this conductor. So in which direction does the force act after these changes? So it acts towards the left hand side of the page. Option C. Okay, question 37. Charge on a proton is E. What is the charge on an electron and what is the charge on neutron? On an electron the charge will be minus E, neutron is neutrally charged, so charge is 0. That is option D. Okay, question 38. The diagram shows alpha particles incident on a thin metal foil. How does the motion of these particles give evidence for the nuclear atom? Okay, so what's happening? This is Rutherford's experiment, similar to Rutherford experiment, right? So some of them are passing without being deflected, some of the alpha particles are getting bent through different angles, and very rarely an alpha particle is being thrown back, is being deflected back, right? Option A, most particle passing through with minimum deflection show that the atom is mostly empty space. Yes, that is the correct deduction. That is what even Rutherford said, that because most of them pass through undeflected, they are not going very near to the positive charge, and therefore atom is mostly an empty space where the positive charge is concentrated in the middle and which is very tiny compared to the size of the atom. Okay, question 39. Radium 22688 is an alpha emitter. It is implanted inside cancerous tumors. It is safe to use as it kills the cancerous cell but not the healthy ones surrounding the tumor. Which properties of alpha particle compared to other emission enable the use of radium 226? Now radium 226, as it is an alpha emitter, alpha particles do not penetrate much, right? They cannot go through a very thick glass, a very thick wall, right? So they will not be able to pass through a lot of tissues inside the cancerous tumor, right? So the ionizing effect of alpha particle, it is high, right, which helps in killing these cancerous cells. Penetration of alpha particle is low, so the surrounding alive cells, the healthy cells, will be safe. So option B, where the ionizing effect is high but penetration is low. Okay, let's go to question 40. The graph shows activity of a radioactive source over a period of time. What is the half-life of the source? So what is half-life? When the activity becomes half. So from 120, the time in which it becomes 60, right? 60 is half of 120. The time taken is 2 minutes, right? This first interval is 2 minutes. Let's double check that by finding one more half-life, that from 60 to 30 the activity becomes half, and therefore this is the second half-life that happens from 2 to 4 minutes, which is again a gap of 2 minutes. So what is the half-life of the source? It gets halved every 2 minutes, and therefore the correct answer is option B. Which brings us to the end of this paper. If you have any doubts, you can mention it in the comment box below. If you have any request, suggestion, or do you want to request a paper for us to solve? You can do the same in comment box below. Thank you for watching. Please like, share and subscribe.